Alright, so here we go. These are common questions that a lot of people have, okay? They're dealing with piecewise functions. Here we go. Find a and b so that f is differentiable everywhere. Which one must come first? Something must be continuous to become differentiable, or something must be differentiable to become continuous? So continuous needs to happen first, right? And then you can check differentiability. Okay, so let's look at this like this. So continuity versus differentiability. We're looking at what if moments. Okay, so let's say what if x equaled what? 2. And what if, whoops, what if x equaled what? Also 2. Nice. Okay? Here's my at moment. So continuity-wise, if x equaled 2, on the top function, I have 4a plus 1. Right? On the bottom function, what do I have? 2b minus 3. And for it to be continuous, what am I going to do with these two equations? Set them equal to each other. Okay, here we go. So now let's create a small little equation, like a system of equations. This would be 4a minus 2b is equal to negative 4. Okay, let's come over here on differentiability. Differentiability, you're going to use this, but you have to first get the piecewise function for the derivative. So we're going to find what is the piecewise function f prime of x. What's f prime of x? Okay, wait. A through e is a good thing to remember, that a through e are constants. I know f is not a constant, but for the most part, well, that's where the functions start. But a through e is a good way to remember that they're constants. And a good way to remember that is because e is what? Constant. Right? Euler's number that we learned back in, what was it? Pre-cal? Yeah. Okay, so what's the derivative of the top line? Anyone? 2ax. Plus what? Plus 0. Well, we don't need that. What's the derivative of the bottom? b. Now, it's if x is less than or equal to 2. It's if x is greater than 2. Let's use our what if moment. Our what if is x is equal to 2. So if our what if moment is x is equal to 2, what would our first derivative equation be? 4a. What's our second one? b. And they must be equal. Okay? So yes, you can use substitution now if you want and just put 4a is going to be right here. So that I have 4a minus 8a. You'll see what I'm doing? It's going to be a negative 4a. So a is what? 1. Therefore, b is what? 4. Y'all see how we did that? Yeah. We have the continuity section, and then we have the differentiability, all at that same surrounding at moment. Okay? To be differentiable is to automatically be continuous. True or false? True. If you're differentiable, you're automatically continuous. To be continuous, you're automatically differentiable. No. What's a good example of that? What current function? Cusps. Absolute value of x. Nice. Because the differentiability is really coming from here. You see what I'm saying? So you're testing, this has to happen. But of course we have to see this to make sure that it does happen. Because I'm treating A and B as constants.
Right, but like, so you have AX squared plus 1. How do you get 2AX from that?
Because the derivative of this, you do the power rule, so it'd be 2 times AX to the power of 1, because it's n minus 1.
Oh, okay.
You see that? Here's another thing that you could do if you didn't see that. Move the A over here near the door. Because I'm trying to use what? I'm using constant multiple rule. You with me? So move the A off to the side, and what's the derivative of x squared? 2x. Now multiply the A back in, because of constant multiple rule, and that can help you see it a little easier sometimes.
Okay.
Any other questions that you guys have? We still have time.
There was one on the website. It was like the 10-point tutorial one. Like, so when we were going through the tutorial thing, it wasn't that hard, but I don't know how you do it all in one step by yourself without having to go.
So the 10.1, I think that is kind of closely related to this one that I'm about to show you. Let me pause the video. Alright, our second example, we're trying to find k such that the line is tangent to the graph of the function. So this is my function, okay? And this is my line, and I'm going to borrow different things from both of them to find k ultimately, okay? Here we go. First of all, if I were to take the derivative, what's the derivative of k times x to the 1/2? 1/2 k x to the negative 1/2, right? So it's like this per se. Whoops, maybe let me make it a little bit clearer by moving it down. So 1k over 2 square roots of x. This is my derivative function. Cool? Alright, and the derivative is equal to a slope. What's the slope that I'm going to take from the line? 4. So 4 is equal to k over 2 square roots of x. This almost feels like the piecewise function that we just did, and it was the second column over here that we were looking at, the f primes with the what if moment. Okay? We're creating the what if that the slopes are equal to each other. Okay? So now let's do the continuity. So this is like the differentiability part of that piecewise that we were doing earlier. And we're about to do the continuity, the position. Okay? So all of this is y. Okay? So that's 4x plus 16 is equal to that. Do y'all see what I did there? If all of this is y and y is f of x, then I can say that this is like the position with the function that it was given to me. I'm comparing, see over here I was comparing slopes to each other. Over here I'm comparing positions to each other. Does that make sense, guys? And then now what we can do is we can go substitution route. 4x plus 16 all over root x. Or however you want to do it, you could have solved for x if you wanted to instead of k. But you're going to put that all over here where k is at, so that you're creating this at moment between both levels, right? Position and velocity. So that you would have 4x plus 16 over root x, all divided by 2 root x. And if you do the math, you know that you can just bring that up right there. Are we good? So again, let me show you real quick. All divided by 2 root x is the same as what I just showed. Whoops. Come back. Is what I showed as far as moving this to join that square root of x in the denominator. Okay? And you know root x times root x is just x. So you have a 2x over here on the bottom right. And we can do what Omar was suggesting with that other equation earlier. Right now, we can multiply both sides by what? 2x, right? So we'll get 8x, 4x, 16. Subtract, divide. And now that we know what x is, we can plug it in here and here to solve for k. So we have 32 over 2, right? And then you get 16. So k is 16. Big, huge conceptual question for sure. Okay? Let me see if I can find that other one. Okay, our last awesome question to look over from our homework was this one, 21, from that first homework that was due. Find an equation of this parabola that passes through 0, 3 and is tangent to this line at 1, 0. Okay, so what we're going to do first is, we know that on this function, I'm passing through 0, 3. So where am I going to plug this 0 in, guys? X and X. Where does this 3 get plugged in? Y. Because that's the position. So I have 3 is equal to C. Do you agree? Because those other ones zeroed out. So what my equation actually really is, is 3. Based off of that point. Almost thinking it like a y-intercept. Are we good? Okay. So now, it's tangent to this line. What are we going to steal from this line that we care about? The slope. What's the slope? 3. Go with me? Now, if the slope is 3, and it's occurring at x is 1, am I going to plug that here? No, I'm not. Because I'm talking about slope. So I need to do what? I need to find the derivative. I need to differentiate this thing. And what's the derivative? 2ax plus b. Nice. Now, I will use this x because this is where the tangent is occurring on the derivative. And guess where I'm going to put this 0 right here? For y prime. Yes or no? No, I'm not. Nice catch. Because this right here is a position of 0. Nicely done. What is it that I'm going to end up putting right here for y prime? 3. Because that's my slope. Huge conceptual question for sure. So I'll put 1 for x, so I have 2a plus b is equal to 3. Questions? Okay, so now that I have this, what could I do with this? Where could I go from here? I can solve for a and b, right? I can solve for a and b as a system of equations. I have an a or b from a derivative level, and it is 2a plus b is 3. That's the derivative level. But now I need, one from the function level, from f of x. So from my original, couldn't I just use my original y value was 3? Y'all with me? And x was what? 0. Or would that work? That would 0 out, right? So I can't do that. So I need to use my 1 value. I need to use this 1 value right here and right here so that I get a plus b. Go with me? Plus 3 is equal to what over here? 0, because there's your position. That's the 0 that you grab, because that's your position function. There's a lot going on in this problem. If you need to rewind it when you go home, that's fine, but a lot is going on in this problem. So that I would have a plus b is equal to -3, and then yes, this is just normal systems of equations back in algebra 2. All right, nicely done.